universal gravitation is this bad boy. We got force of gravity. Gravitational force is equal to G m1 m2 over r squared. So what do each of these variables mean? So F sub G is gravitational force. Capital G is Newton's gravitational force constant. All you need to memorize, you don't even have to memorize that. I'll give this to you. This is always 6.67 times 10 to the negative 11th. That is a constant, does not change. M1 and M2 are masses of two objects, and R is the distance of separation between the two centers of those objects. So what is the unit for gravitational force? Well, it's a force, and so it's in newtons. What would cause the gravitational force to increase between the two objects? Well, looking at this equation, capital G, that doesn't change, but if you increase one or both of the masses, that's going to cause gravitational force to increase. But also if you decrease the distance of separation between the two objects, bringing them closer together. So any of those combinations will cause increased gravitation. So is there a gravitational force between you and your computer? Crazy thing is, yes. So fact, there's a gravitational force between you and any other object in the universe that has mass. So which way is it acting on you? It's pulling you towards your computer. Which way is the direction pulling on the gravitation pull on your computer? It's like it's pulling you towards it. So why aren't you like, oh man, my computer, gravity, squeeze me in? So the reason why is because the gravitational force is super weak. Why is that? Mathematically, you get this G factor, this gravitational force constant. Look at that, times 10 to the negative 11th. Is that a big number or a small number? And it's a crazy small number. So that's making gravitational force really small. Unless you've got really big objects, like planets and such. So inverse square law. This is just kind of a thing in science we observe. Essentially, inverse square law means an equation follows this pattern: y is equal to 1 over x squared, and we find that in gravitational or the gravitational force. And so you've got G is equal gravitational force is equal to over r squared. So what that means is it drops off quickly, gets weaker and weaker. Those are just some visuals to help you see that. So the Earth is orbiting the sun. We know that. What's the shape of the path the Earth makes around the sun? It's a circle. So what's playing the role of centripetal force on the Earth to make it move in a circle? Gravitational force. We've seen this, huh? So if your problems have to do with planets or satellites orbiting, then you need to start with this basic equation. Centripetal force is equal to gravitational force. More to come.